And we're live.
Yay.
Welcome, people. Hey, sorry about the little delay,
It was all
but
Matt's fault.
it's all my laptop's fault, unfortunately. And and I was actually evidently going to stop the stream just then. Okay. All right, guys. Welcome to the Perth Observatory virtual star party for the April the 21st. Hopefully, I'm checking all my sound and it's coming through. So hopefully you guys can hear me. So just if you can let me know in the chats, that would be great. Because last time there was about 2 or 3 minutes of me me and Riley talking, and it was just completely silent. And then we realised what's happening. So we've got Belly talking, and while we're at it. Hello to Belly on the chat here in the Discord channel, and if you guys do want to ask any questions, let us know. You can join the Discord channel. Good, and Queens of the Star Cars as well. Hello. You can join us in the Discord channel. There's a link down in the description of this video, so you can ask your questions. And we've also got any soup. Unfortunately, I don't have any soup.
I had soup for dinner. It was amazing.
But we've also got Brody Johns. Hey, how you going, guys? And Nicholas Bell is here as well. So thanks very much, guys, for joining. Now, if this is the first time you've jumped in and wondered what the hell you've got yourself into, don't worry. I ask myself every single time we've been doing this.
And I keep asking myself why I keep agreeing to this on a Tuesday evening when I'm like, oh, come on.
I know. Yeah. Now, if you don't know who this other person is that's talking, that's okay. It's just another volunteer. They're just here to help. I know this is Moira. Welcome back, Moira.
Hi.
I think it was about a month ago we had you on as well.
Roughly, yeah.
Yes. And this time you're not in our war
Less
ranking.
supervillain.
Yes.
Less supervillain and less cold because I'm not out in the wind.
Yes. And also making its triumphant return is the Meade 14, which we haven't used on the night sky on the virtual star parties for a good couple of months now. So we're actually using a telescope. And if you hear any woots and cheers, that's because Roger, who you've all met on one of these live streams, he's running a Spring into Milky Way workshop. So we've got about 15 people learning how to take photos of the Milky Way. So they're just super, super excited. We've already heard some whoops and wahs. So
they're all literally right behind me because I'm actually in the Meade 14 domes. They're all behind me, and I've just got everything closed in here, and I've got an amazing view. Don't know if you got. Can everyone see the view yet?
Not just yet, but I'm about to show them. But Queens of Cars said hello.
Hi.
And also Belly. Oh, and Nicholas Bell is Belly. So and Dor says yo, and any soup says they're glad to have clear skies. And
I was actually a little worried about that coming up the hill. I could see all of this smoke coming out over Perth. I was very worried that we were going to get some interference up here, but thankfully it's all nice and clear up here at the domes tonight. So
yes,
that's awesome.
And that's good for the workshop as well. Okay, so first of all, what we're going to be doing tonight is what have you got on first?
Well, I figured we'd start with the moon.
Yeah, we've got to start. We've got to start with the moon, don't we?
Considering I've got the filter in and everything, I've got it all. I've got the video going. We're all good.
Awesome. So if you don't know where the moon is at the moment, it's that really, 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 really bright thing in the north. So there's our Lowell Telescope Dome, and that is turning 50 this year. And we're going to have a special night public talk this Saturday. If you want to, there's still tickets available, 7 p.m. and we're going to have food beforehand and doing guided tours from 4:30 as well. Which, if you book, you can come to both. But this is what we're looking at: this big bright ball right here, and this is what it looks like. So, ooh, looking very nice.
I've actually got a moon filter on the camera at the moment, so that's actually cutting out most of the light that's coming down.
Unless we'd be blinded, wouldn't we?
Well, I could still video it at a slightly quicker shutter speed, but this is easier.
Yeah.
Let's not mess with easier.
So we've got a first quarter moon there, and you can see the giant bunny rabbit right there, can't we?
Now, this is an argument that me and Tom used to have all of the time, and I'm saying literally all the time, because Tom, who's another one of my the volunteers here, and he's also my husband, he is actually from the UK, and we used to argue about it. No, it's a bunny rabbit. No, it's a man in the moon. It's a bunny rabbit. What I didn't realize until only a couple of years ago, it's flipped upside down. We are literally looking at it upside down.
Yeah, they're just looking at the wrong way. We're in the southern hemisphere.
It just didn't realize at all, and then it was like, oh, okay. I saw a meme online. I was like, oh, well, that's why we've been having this argument for the last 10 years. We're both right.
He's kind of right. He's just wrong for the southern hemisphere.
Mm-hmm.
So yeah. So we've so if you're in the northern hemisphere, you actually see the man on the moon. So if you see the down the below, you can, do you want to just circle the Sea of Tranquility?
That's this one here.
That's that's the middle one. That's the head of the bunny rabbit.
This one here. Oh, the head of the bunny rabbit. That one there.
Yep, that's right. And the sea, the one down the bottom there, that is the Sea of Serenity. So if you're a Seinfeld lover like me, you know what to do. Serenity now. Insanity
now,
later.
where did Apollo? Which one was it? Was it Apollo 11?
Apollo 11 and actually Apollo 17 landed around Sea of Tranquility. So on the bottom. So on the just have a look. I'm just trying to have a look. No, just trying to figure where it is. Let's have a look here. Because it is a little. I've got it. The problem is it's flipped. And so I'm trying to do my mental gymnastics.
It is a nice clarity, by the way, Belly. Yeah, it is. I was really surprised by how clear I could get it. I'm getting a bit of atmospheric interference, but it's not too bad.
Okay, so where your arrow is right now, that is where Apollo 17 landed. So that was where.
How is that? How is that?
Yeah, so that is where Gene Cernan and Harrison Schmitt, who was the very first non-test pilot astronaut. He was actually a geologist. They landed right there on the opposite side of the Sea of Tranquility.
So up about here?
To the right.
Left
to the right.
right?
To the, yep. Right there. That's where Apollo 11 landed. So that was Neil Armstrong and Buzz Aldrin. And so, yeah. And
what really surprises me, though, is when I found out that the moon itself, like if you're actually on the surface, the rocks under your feet are actually about the same color as coal.
Yes. It only reflects
about... It looks so bright all the time.
It only reflects about 7%. So, but if you move your mouse just further down to the Sea of Serenity, to the bottom right.
Down here?
Just a little bit up.
Up a little?
Yep, around there. That is where Apollo 15 landed.
Ooh.
And that is where they found the Genesis stone. That there is where Dave Scott had the infamous word, or the famous words, guess what I just found? I just found?
What is the Genesis stone?
Genesis rock is a piece of anorthosite, so it's the original piece of the moon. And cool. So what was happening was, up until then, they'd been bringing back pieces of basically basalt. So basalt, which is ancient lava flows, it's quartz, I think. There was silicates and all that kind of stuff. And it was just, it wasn't the original crust. And this actually was, we were able to then, using this rock, find out what the moon was made up of
Oh
when
wow.
at the very beginning of its formation. And out of that, Bill Hartman, who was a um, moon scientist and who worked on the moon rocks, and also a lovely painter as well, he came up with the idea of the collision method. So up until
Oh yeah.
then, the thought was that the moon had come from the Earth either spinning too quickly, because as the moon's moving away from us, Earth is slowing down in its orbit. So imagine like an ice skater where they're in a spin. I've never been good enough to do that. Um, but when you put your hands out, you actually slow down. But when you bring your arms in, you
You
actually
can
speed up.
actually you can actually do this on a computer chair as well. You can do that with your arms. I've seen
Yep.
people do it. It's quite
Yep.
fun.
And you can do it at SciTech as well. They've got like a little experiment there where you can do that. And but so if you bring the moon
Cool.
closer to Earth, Earth speeds up. So they thought, well, maybe what's happened is that the Earth was spinning so quickly, it just flung off the moon. Another one was it was captured. It was formed somewhere else, and then got captured by the Earth, or it just formed at the same time with the Earth. But what we find with the anorthosite is it's very it doesn't have a lot of heavy elements, so stuff like iron and all that kind of stuff.
Mm.
And so Bill Hartman came up with this idea of that it was something about the size of a Mars object hit the Earth, so something half the size of Earth hit Earth, and they call it Theia, after the Greek god and goddess actually, sorry, and that nearly destroyed the Earth. But
Oh wow.
in the process, it actually formed a ring around Earth, and out of that ring, you got the moon. The moon formed in about 100 million years. And one of the interesting things that's just been coming up in the news recently is that they've been able to do some more seismic readings of what's actually underneath the crust of the Earth, and they think they're actually seeing bits and pieces of Theia in the mantle. But it also
Oh
gave
cool.
us, but it also gave us a massive big iron core, because Theia's iron added to our iron core, which means we've got a nice strong magnetic field to protect us. So yeah, it's
Well,
pretty.
just going back to the Discord here,
Hmm.
we've got a couple of comments here from Gluttony Soup. I think the descent stage of Apollo is still there. I think we were referring to Apollo 17. That was when that came through, and they
Yeah.
got something similar to the Genesis stone from Mars. They call it Black Beauty. That is so cool.
Mm. That's a
I
much better
I
name.
I definitely think so. Genesis stone is kind of like Black
Yep.
Beauty. Yep, I'm so
And
totally there.
Got Any Soup also mentioned earlier, is the moon entering its gibbous stage? Yes. So this weekend it should be a full moon, which is horrible. We hate full moons.
Actually,
Terrible.
that was another thing that kind of made me kind of like, wait, what? When I realized that we're flipped upside down compared to the northern hemisphere, it also for us the moon phases go in the other direction.
Yes. Yeah.
So that when we see a gibbous moon, for them they're thinking for us it's going up to a full. For them it's coming down from a full, and it looks the same. So I was just like,
Yeah.
wait, what?
It's funny because I get a lot of emails from people and doing calendars and teachers who are wanting the correct moon phase, because they you put in moon phases and you get a lot of it is actually the northern hemisphere view of things. So again, we're different here in the southern hemisphere. Hello to all our northern hemisphere friends over there who might be watching. We hold no grudges against you. We just
Which
have
is
all
better.
we don't
No,
want,
we're not.
we've got all the best stuff, but we don't want to rub it in their face. But once the coronavirus situation
Hey,
settles,
they get the easier polar alignment. So
yeah, but nothing's nothing. Well, is it what's the term, like not? Is it, nothing great is God damn it! Sorry, but
What anything great?
anything
is worth waiting
worthwhile is
for?
worth doing. Yeah, that's it. Yeah, sorry for my mental blank there. So it's been a long day,
It has.
and yeah, and
I just
also
think it's
Brody
really cool
Jones.
because this time of the day, the month, so to speak, is also the time when I'm just moving the telescope here. If you look right up the top there, you can see this is the best time to see all the divots and shadows and just along that terminus line down the middle.
Yep.
And you can see all the craters and stuff, and just how cool is that?
And we've actually got a couple of questions. I was just checking. Hey, Stephen, in the YouTube chat, question: why does the moon turn red if there is smoke in the air? So that is because actually it's very similar to why there is an orange moon on a total lunar eclipse. So the reason the moon is turning orange is because that light is having to go through the smoke. And so it is blocking out some of the light from the moon, and so we're really only seeing it as it is red. With a total lunar eclipse, what's happening is that the actual moon is going behind the actual inner shadow. So that's called the umbra. So the Earth has two shadows. There's the umbra in the middle, and then fuzzy around it is called the penumbra. Penumbra, sorry. And and when the moon comes in, I need to get some little toys to do this. So the moon will start to move into the penumbra shadow, and you won't really notice much. It's actually when it starts entering the umbra that is when you start to see the traditional moon starting to be eaten.
And then so it's basically the sun with that the sunlight is hitting the moon to a certain extent as well, but it's going through our atmosphere to do it.
Yep.
So
when it's completely
our atmosphere is blue because it's cutting out. It's basically reflecting that blue light. So it's
because
just
of
the
oxygen
red that's getting through.
Yeah. So just because our atmosphere is nitrogen and oxygen, which is we need to breathe, that scatters. It's called Raylene scattering. And so that scatters the blue light, and what's left, light's made up of three colours: red, yellow, and blue. And when you've only got red and yellow light hitting the moon, it turns orange, and so that's where you get the orange from. And Brody also says, I've mined through basalt in Ravensthorpe. It's the most difficult rock I have ever encountered.
Now, one thing that we've got here is Belly has asked, that looks mint. What does it look like without any filters like my pics earlier? Can you show that now? If you give me 2 seconds, I will do so.
Yeah.
Oh.
So, and you can mess around with the settings of your camera so it doesn't take... so it takes brighter images and all that kind of stuff as well. And there is going to actually be a total lunar eclipse on the 26th of May. And it's actually at a reasonable time as well. So on the 26th of May, the beginning partial phase begins at 5:45. And so if you want, you can actually book on our... we've got our lunar eclipse event, which you can come on. And you can just book through the website. You're getting wobble effect, wobble vision here.
There we go. So that is without the filter. So as you can see, it's quite a bit brighter. Yeah, it's quite a bit brighter there. There's not as much light being cut out, so you're kind of losing a little bit of the detail there.
Yeah. And for people why you don't understand why we don't like the moon, because it's the second brightest object after the sun. It's actually about a quarter of the size of the Earth, so you can actually fit it in between Perth and Sydney, but it is the largest planetary satellite relative to its parent. So before Pluto got kicked out of the planet system, the Planet Club, technically Sharon was
Pluto is still in my Planet Club. Thank you very much.
I I think geology also has to take into a factor, but hey, unfortunately, I'm only an amateur astronomer. I'm not an astronomer. But it's also the fifth biggest moon in the solar system. So there is Jupiter has Ganymede. It has and then
Io?
Saturn. So it also has Io and Callisto. Callisto's
Europa?
actually
Europa?
yeah, but Europa is actually smaller than our moon. So
Oh, is it?
it is, yes. So it goes Ganymede, then Titan, Saturn's moon, and then Callisto, and then Io. And all the Galilean moons are actually named after the lovers of Zeus. So, yes.
So, sorry, when we've got a question here from God in His Soup. Could I look at the eclipse with my telescope? If we're talking about a solar eclipse, please don't.
Hell no. No, don't do it. If it's a solar eclipse, no. Just no. But total lunar eclipse,
But I think that's
yeah.
kind of an obvious one there. But yeah, total
Yeah.
lunar eclipse, you should be okay.
Actually, I can show you what I took. Let me just pull up a... Sorry about this.
Now, while you're doing, are you going to show something on the screen there, Matt? Because if you are, I'm going to skew to the next one.
Yeah, just give me a sec, because I'll just show them a photo that I took for the total lunar eclipse.
Well, I'm going to stop sharing my screen just for a second, because then I'm going to be able to switch to the other piece of software that I've got that will help with the rest of it.
All right, cool. Just... You know when it just thinks it's only going to take a second and it doesn't?
It's always the way. Hang on, I'm just going to go back to the other thing.
All right.
So I'm going to skip that second object and I'm going to just go straight for the third.
All right. Just zooming in. So don't worry, people. Your screens nothing's gone wrong just yet. But yeah, this is
you haven't broken everything yet. Just give it time.
There you go. So this was a shot that I took from the 2018 July eclipse. So thankfully, it decided to clear up just as we entered totality, or when it turns orange. And so this was taken with a camera, but when you did look at it, it did look slightly. It looks slightly dimmer than that because it's not getting so much sun on it. So yeah, sunlight on it. So there. So we'll go back and so did we want to have a look at Regal? Do you want to try Regal or?
No, I'm gonna go straight to the next one.
Okay.
Oh. Alrighty, I'm gonna have to move the dome.
Here we go, and you can actually see it in the background moving. Yes, if you haven't seen one of the earlier streams, the actual dome for the 14-inch, which we lovingly call the octagonal dome because it's octagonal, it rotates on itself. So it actually can rotate.
We're so imaginative.
It can rotate 360 degrees, but due to not all the concrete going all the way around, we've limited to 330 degrees, and that 30 degrees is where most of that 50 degrees around that area. That's where we show a lot of stuff, and so it's either a toss of the coin to see which direction you need to go, and then most of the time you've just got to go all the way back. So,
alrighty, we should have another window back up. Yep. So this is my deep sky window.
Okay, so
let's see what we can find.
Alright, so
it's not going to be too good to start off with, but that's just because I'm getting the initial photo.
And this is Southern Beehive, is it? Ooh, nice.
Does that look about right? Doesn't quite look right.
It does.
Hang on, let me go with continuous and then see what happens.
Yep. So while you're just working on that, I will transition to Stellarium. And we're going to be
Oh,
going.
no!
We didn't hear that.
No! What are you doing?
Did it just do that on its own, did it? Okay.
I had speed at maximum. I was just like, no, don't move.
So, also, if we're having a look again for the newcomers, this is our VOF, what we call the Visitors Observing Facility. We've got we've got our Calver telescope in. We look on that through that on our night sky tours here at the observatory. We've got the Millennium Dome. It's got our Meade 16 in there. If you want to know where Moira is right now, that's the octagonal dome right there. Now the difference is that we've got a whole heap of people. This is all cemented now. That happened before I joined in 2014. There's a whole heap of astrophotographers taking photos around this area, and the octagonal dome's shutters should be open, and inside, Moira should be inside there with the telescope as well.
Tucked away from the wind. Now, I noticed that we've got a couple of little questions here. So, got any soup? Is it hard to find deep sky objects, or is it easy once you know where they are? Depends on the object. There are certain ones that you can see with the naked eye, such as the Orion Nebula. Yeah. You can actually see that one with the naked eye. You can kind of get a bit of an idea where the Omega Centauri is, but it's really on the really bright dark sky objects that you can see. With the rest of them, you know where they, like, once you know where they are, you know where they are, which is great, because, you know, I don't really know my way around as yet. But, you know, the guys up here have helped me out considerably with that. I can now kind of figure out where the jewel box is these days. I'm quite proud of that. Yeah. Lots of practice with the Calder.
The annoying thing is when you can't actually you can't see it in the phonoscope, or it's really blurry in the phonoscope, and the telescope goes. Someone hasn't packed it. It's normally because it hasn't been packed up properly, and beforehand. So you go and set it up, and then it doesn't always go in the eyepiece, or it's just outside the. Or someone's knocked the findoscope. That's the annoying issue.
That's the hardest one to deal with, is when somebody's knocked the findoscope and then you've got to go and realign the findoscope. But yes, I will show that telescope who is boss, and I just did. So let's go and get a good exposure, shall we? So I'm actually going to do a 60-second exposure and see what we come up with.
And this is where we're looking, right here. Lovely. Well, it's also called the Sprinter Cluster. It's also known by its name, the Diamond Cluster as well. And it's also known as the Beehive, Southern Beehive as well, because it looks like the Beehive Cluster, which is in the our northern sky as well. So we're looking quite close to the South Celestial Pole. We've got down here the Large Magellanic Cloud. Down here we've got the Small Magellanic Clouds. These are two dwarf galaxies that orbit around our galaxies and will one day be consumed by our galaxy. Yes, our galaxy is like the Borg. Resistance is futile.
Yes. Until Andromeda gets here, and then its resistance will be futile on our side of things.
Yes, yeah. We'll payback is
Ooh, look at that. Haha.
All right, let's have
pretty.
A look. Oh, sorry, just got to move my studio view. Okay.
I'm going to stop, and I'm actually going to, while you guys are doing your thing.
There you go. No, we're having, it's on camera now. Yeah. That's looking very nice.
Yeah. Yes. So, sorry, I don't know if you can see my other bit, but I'm about to take 25 frames of that. Thank you very much.
So Door's saying what you guys are doing right now would be what? Professional astronomy or something else? I really wouldn't call us professional. We don't have that upper class accent to us. But something called astronomy.
It would depend on what the end result you're looking for is. If you're just looking for pretty pictures, I would call it artistic astrophotography.
Yeah.
If you're doing it for research purposes, then astronomy would be right. So it just really depends on what the end goal is.
Yeah.
So
And yeah. So this is the Southern Beehive cluster, and it's a circumpolar open star cluster in the constellation Carina. So that was a mouthful. Well, circumpolar means it never leaves the night sky here in Perth. It's always in our night sky, even during the day. The box-shaped open cluster is because it looks box-shaped, and an open star cluster is because these are baby stars that have recently formed.
These little ones in the middle would probably be roughly about the youngest ones.
Yep.
And these bigger ones at the outside would be the older ones.
Yeah, so they're high school age, so they're getting kicked out. And so this is the next stage after a nebula, which is a star nursery, so something like the Orion Nebula. And so all the dust and gas has been used up, and you've got stars orbiting around each other loosely. It doesn't take a lot for one to be kicked out of the system and told to go on your own way around the galaxy. But yeah, this is 1,300 light years away from us. So the photo Moira has just taken is of light that has travelled 1,300 years to get into your eyes. So you were talking
Let me look it up. I'm going to look it up. So let's see. What year is it? It's 2021. So we're going to be looking at 721. What happened in the year 721? So that would be... Yes, thank you. Events. So let's have a look. The Battle of Toulouse in France.
Yep.
Happened. King Ian of Wessex defeats Prince Cynewulf, an unknown relation, making a push for the throne of Wessex. So this is before the United Kingdom was even a kingdom.
Yep.
A proper one, anyway.
And the Battle of Toulouse was after a besieging of Toulouse for 3 months by the Muslim forces under the governor there. And
here's another interesting one. The rains and heavy storms around the southern seaport of Yangzhou in China destroyed over 1,000 ships and boats in the Grand Canal during the Tang Dynasty. So, bit interesting thing from Asia there as well.
Yeah.
So, it is the closest we've come to that will probably ever come to time travel. So, you know.
Yep.
But it's interesting to think of, what was happening when this light was being created 1,300 years ago. So.
Yep. Yeah, it's amazing. Telescopes are basically historical objects. They show us what it looked like, and if you could transport yourself from the Earth straight there and be looking back at us instantaneously, you would see us back in the Romans. During those times, so yeah. But it's the actual cluster itself is also 10 light years across. So imagine light taking one from one side to the other side.
Sorry, no, you wouldn't. You wouldn't. You would be looking if you went back to when this light was being created. You would be looking at if you were looking back at the Earth, you'd be looking probably at ancient Egyptian times, because there'd be 1,300. Years in the other direction.
No, because it's instantaneously. I'm saying I'm not trying to do Star Trek. Sit on your rear end in a spaceship.
Hey, Star Trek is cool. Star Trek is cool. You can't tell me different. I will never accept Star Wars. Always Star Trek.
No, I have nothing. As I've said to Roger many a times, I have nothing against Star Trek. I am Star Wars and Stargate. I don't have anything. It's a decent TV show. As long as it's not Real Housewives of Star Trek.
Oh, God, no.
I'll never watch that. Or Real Housewives or Husbands of Star Wars. But yeah, so it's also 150 million years old. So it's pretty decent. It's about, probably some of those older stars are getting to that late teenage reference for humans. It contains 100 stars. And it was first discovered by by Nicholas Louis de la Caille in 1752, and it is a naked eye object if you're in the country, and it's also a good binocular object as well. So it's also called C96 in the Cadwell catalogue, which was compiled by Sir Patrick Moore. So if you don't know who Sir Patrick Moore is, put into YouTube The Sky at Night, and I think it might be BBC, was it? And Sir Patrick Moore was a fantastic outreach person who taught a lot of probably people older than me. He was probably he was a little bit before Carl Sagan and during Carl Sagan's age. He only just passed away a couple of years ago, but he couldn't use M because that was the M catalogue was already taken up by Charles Messier. So he used C because his surname was Cadwell Moore. So, but it's not even visible to from 32 degrees north always. So all of the UK, Europe, north of the Mediterranean and northern US can't see this object. So again, it's another one for...
You were pretty lucky down here, that's for sure.
Yeah. Yep.
Now, one of the interesting things as well about these open clusters is the way that they work out which stars actually belong to it, because you can see in the background you've got all of these tiny little stars around it, and it's really hard to kind of figure out from the naked eye which ones belong to this cluster. The way that they do it is that the light that each of these stars gives off is like a fingerprint, and they basically match up the similar ones to work out which ones belong together, which ones came from the same nebula, because they have roughly the same light signature. And that's actually how they've worked out in our local area around the solar system. There's about 39 or so different stars that have a similar like signature to the sun. So they might actually be the sun's siblings from when it was part of an open cluster.
Yeah, I think.
How cool is that?
Yeah, I think they think the actual cluster that we would have come from was actually from was in the constellation Cancer, the Crab as well.
Oh, so, wow!
Yeah. Thank you, Tom, for putting that up.
Yeah, he's got the Google going.
Yep. Welcome.
No. What it is he's keeping an eye on me and making sure I am where I said I would be. Because he's there. He was always, when I'm driving, especially with all these fires going, he worries about me. He's such a worrier.
Yeah. Well, we hope you feel.
Wouldn't have him any other way.
Yeah. Also, did you want to have a try to go to Rigor? It's a named star, so you don't have to use SA.
Well, I tried using the named star thing in here, and it didn't actually come up. So
let's have a look.
Maybe it was just the time of day. Let's have a go.
Behave yourself, telescope. Behave yourself.
No, I'm going from Regulus to Rigel. So.
Okay.
Are you sure it's? Hang on, let me. Has it got any other? Is it in any other catalog or just the SAO catalog?
No, it does have other ones. I'm just gonna check for you right now. So now,
Tom Guy in the Royal Telescope.
We do have the We do have the Henry Draper catalog, the HD catalog.
I don't think that one's going to be on this.
Okay. Do you want to try? Go to SAO. Go to SAO, the Smithsonian Astrophysical Observatory Star Catalog again. I might have given you the wrong one. It was 219.
219.
501.
501. That actually does sound like you gave me the wrong one. So object not found.
Ooh.
That's a bit of a worry. So hang on, let me try that again. 219.
219. Yep.
501.
No, sorry, 4. You put 4.
4.
Yeah, it's 4, not 1.
401. Okay.
No. Sorry. Sorry, this is
So he's not allowed to navigate. Just so that we're clear, he's not allowed to navigate.
no,
Just take the map off him.
Okay, so you got it there. It's 2. It's 219.
Hang on, let me get back into. Come on, mode. Which one are we looking for? I can't find it now. What have you done? Hang on, start.
So while you're doing that, Brody says, "Can you see the nuclear bulge of our galaxy from the observatory?" Yes, you can actually see it. It's a little bit faint, especially with the moon up in the night sky, but you can actually see it from the observatory. We don't have that bad a light pollution, and it's easy to see in the nights. In the eastern sky, you really have to kind of give up on anything really 40 degrees in the and below in the west, because there's just there's too much light pollution there as well.
Ooh, I'm running out of battery.
Billy is asking, is coffee is that coffee in your mug, Matt, or bourbon?
Oh no, I'm running out of battery and I didn't bring my cable with me. I'm sorry, guys. I can't believe this.
Okay,
I charged it up fully.
All right, we'll keep on going. How long do you have?
I've got 10%, so hopefully we'll be okay. So it's just saying it will go to sleep soon unless plugged in. So hopefully we'll be okay.
So have you got to SAO again?
No, it's not coming up. So let's try something else.
You want to go to M40? Let's go to M40. M68. Let's go there. Because we've only got about 12 minutes to go anyway. So before we've got to let these people go to bed.
Oh, do we have to? Can't we just do this all night?
Well, your computer won't let you. Remember.
Oh, true. But then I can always just use the mead instead.
Well, you can do that. They just have to go to bed.
Yeah. Oh, yeah. I need to move the thing again.
No worries. Oh well, while Moira is doing that, we will go back to where M68 is, and it's
next time I'm packing my power cable. That's for sure.
Yeah. Okay, so M60.
Oh, how are we going? No, not quite. A bit further around.
58. I thought that was it. Right there. So it's quite high. So we're looking.
Nope.
There's the Southern Cross right there. We've got Omega's.
Oh, it was just the cover. It's fine.
Okay. It's already beaten up anyway. We've got Omega Centauri here, which is the biggest globular cluster that orbits around our galaxy. We've got Centaurus A, which we showed. I think we showed last live stream. This one here is M83, and we've actually got a. I think we've got to actually do that again. The Southern Pinwheel. We haven't done that for a while. Maybe next time. And then we have M66 right here, which is a globular cluster. So if I do the artwork here, you'll get to see right here. So it's in the tail of Hydra, Hail Hydra. So you've got the Centaur. And before I was talking about the Sprinter cluster being in Carina. Well, Carina is the...
that doesn't look right. Okay.
Is the bow of the Argo Navis, which was a much larger constellation back before the modernisation of the constellations in 1920, and so we've got Carina, Vela, the sail. Oh, there's Carina, the keel of the boat. The actual bow, I think it's the front of the ship is called. That is called Puppis. I'm pretty sure it's called. I should know. Yes, that's right. Yeah, and so we've got the Southern Cross. We've then got the Centaur around him, or if you've watched Hercules, the little Danny DeVito's carrier Chiron. That's him. He taught Hercules to be a Greek god, demigod. We've got Corvus the Crow. We've got Virgo here as well. We've got Crater as well, the constellation Crater, and Hydra right here, which is actually one of the longest longest and biggest constellations as well. So
I'm just going to interject here. Thank you, Belly. This is only my second time doing the live stream. I'm having a ball. Very much enjoying myself. And yes, I will take him out because Hydra, really? Wakanda forever.
All right. So what are you, Neil? How are we doing there?
We got 10 seconds. We've got, I can see a globular cluster, but it's very, very faint. As you can probably
so
tell.
while it's coming along.
3, 2, 1. Bam!
Hey!
There she is! Ah.
Nice. So yeah, so this is a globular cluster. So we've already seen a open star cluster, and now, which is a very young star cluster. This is a globular cluster. These guys are really, 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 really old. So, and they're very far. They exist. There's about 120 of them above and below the disk of our galaxy, and they're around about the 12 billion years old. And so this one is about 33,600 light years away from Earth as well. So. And it's got a couple of 100,000 stars, about 100,000 stars there. As well.
I'm just going to spin this around for a second so I can actually see what I'm doing, because I'm going to try dropping this one on the mead itself so we can get a bit of a better look.
Yep. And so because it's so old, a lot of the brighter stars have already died. So we're talking about a cluster that's actually about 11.2 billion years old. So what's left are really old dim members, and so it is one of the least concentrated globular clusters. So there is a little bit of space in there. Ooh, whoa!
Oh no, other way. See, focus is a thing.
Yeah.
Always focus your telescope before you try something, but then it's always difficult to do when it doesn't want to play ball.
It contains about 42 variable stars. So these are stars that if you were to take photos over a period of time, you would actually notice that they get brighter and dimmer as well. And they're actually getting slightly bigger as they get brighter. There's also about 200 giant stars. So these are stars that are coming towards the end of their life as well. So, and it was actually discovered by one of Charles Messier's original discoveries as well. So he found this, he catalogued this in 1780, and he described it as a nebula without stars below Corvus and Hydra, adding that it was very faint, very difficult to see with refractors, nearly to at its star of 6 magnitude, because he didn't realise that this was actually hundreds of 100,000 stars, not just one nebula. And but it was William Herschel who was first able to resolve the individual stars to be in the cluster in 6 years later in 1786. So
unfortunately, this is going to be the best I can get with this one. So
that's still pretty cool.
What are you doing? So
auto run.
Yes, auto run.
Yeah.
Auto run.
So Charles Messier was using a refracting telescope, so like your old-timey Galileo telescopes, where William would have been using a Newtonian telescope, so using mirrors. So he was going to get better images of it anyway, and he described it as a beautiful clusters of stars, extremely rich and so compressed that most of the stars are blended together. It is nearly 3 degrees broad and about 4 degrees long, but chiefly rounded, and there are very few scattered stars about. So yeah.
Of course, back in the day, they felt like they had to basically speak in scientific journal terms.
Yes.
It's very, very boring. I fell asleep through many a reading of scientific journals, but hey, what can you do? They didn't have YouTube back in those days.
It was funny because Admiral, not Kirk, but William Admiral William Henry Smith wrongly credited Messier's friend and colleague Pierre Michelin as the discoverer, and there's been a number of sources out there picked up on the error, but he actually saw the cluster in 1837 as well. So, but yeah. So it's relatively metal poor, these stars. So when we say that a lot of the stars don't have, like our sun will have some oxygen, carbon in it, and where a lot of these stars are just mainly hydrogen and helium with a little bit of maybe oxygen. So they're probably they're generation 2 stars that we can see. So these generation 2 stars came from the generation 3 stars, which were the very first stars. These were massive behemoths that were just purely hydrogen and then into helium, and then they blew up and seeded the universe with some of the other elements like oxygen and carbon. And then the next stars came along, also helped clear out and made the universe visible. And then they also gave off more of the oxygen, carbon, and iron as well, so that we have all these lovely elements like uranium and gold and silver, tungsten.
I'm kind of glad though that I'm out here and not in there, because standing in the middle of that, it'd be like Twilight all the time. You wouldn't be able to see anything.
Yeah, and because it's so metal poor, these globular clusters are so metal poor, we actually we haven't found any planets there. So not to say that there are any, but if you were on a planet around, particularly in that center area there, there would be no nighttime. At best, it'd be twilight. So, yeah.
We're starting to get a bit adrift.
And it is 53 light years across as well. So it is on the smaller side. Omega Centauri is about 170 light years. 47 Tucana is about 120 light years across. So it is a smallish one as well. So, yeah. So I'll just have a look if we've got...
I'm just looking forward to, I have to say, I'm looking forward to when I can get some proper pictures of these. Gonna get home, get out my telescope, get it all set up, show it who's boss, as Belly would put it.
Yeah, so that's it's coming up to 9 o'clock. So I think what we will do... who named the Southern Cross? I actually don't know. I've never been asked that question.
Well, considering it's Crux, I would assume that there was somebody important named it. Because that's the thing, like these days astronomers don't tend to have a whole lot of imagination, so you get a couple of letters and a bunch of numbers, and then maybe a couple of letters after that.
Yeah. Let's have a look here. Historians generally...
Let's see.
It could be... I don't know whether I want to even try and pronounce the name, because my pronunciations are horrible.
Let me have a look. Where are we looking? Are we looking
on Portuguese.
On Wikipedia?
Yeah. I think it's Jorge Ferraris.
So it looks like the bright stars of Crux were known to the ancient Greeks.
Yeah.
So Ptolemy would have regarded them as part of the constellation
Centaur. Yeah. Dante might have known about it in his constellation in the 14th century, as he described the asterism of 4 bright stars in the southern sky in his Divine Comedy. The 15th century Venetian navigator Alves Cadamosto, sorry for butchering these names, made note what was probably the Southern Cross on exiting the Gambian River in 1455. And he called it the Southern Chariot. But his diagram is incorrect.
Well, one of my favourite things about the Southern Cross is the fact that I can always remember which star is which, because I'm terrible with that. So the brightest one, which is the one right at the bottom, is Alpha Crux.
Yeah.
And then you've got the next brightest one, which goes, if you're looking at it from the bottom, you go up to the left. That's Beta Crux, and then you got Gamma at the top. You got Delta at the side there, and then the little one's Epsilon, and they go down in order of magnitude or order of brightness. So I can always remember which one's which.
So generally,
that makes me proud.
It says here, another early modern description clearly describing Crux as a separate constellation was attributed to Andrea Corselli, a Italian navigator who from 1515 to 1517 sailed to China and the East Indies in an expedition sponsored by King Manuel I. So there
I'm down to 2% battery here, Matt.
No worries.
So I'm gonna have to log off. But
that's fine.
Everyone,
we'll
it was absolutely wonderful. Loved being here. Hope to hopefully do it again.
Yep.
And next time, I promise I will have my power cable, so we can actually go for as long as we want.
And thanks, guys, for joining us. If you liked what you've seen, please tell your friends and family. And also
the whole like, comment, and subscribe thing.
Yes,
we've got to do the like, comment, and subscribe.
Yep, and hit that notification bell so you don't miss it.
And not see us on Facebook. We're on Discord. We're on Twitter.
Yep.
We're on the internet. We do the live streams. We do the live tours on weekends. We also have workshops like the one that Roger's doing at the moment. And if you want to come up and help us out and come and do the volunteering thing, come do it. It's amazing. You don't need to know everything about stars, because I certainly don't, and I came up and I learned a lot, so awesome.
Yep. And so the next one, I'm just double checking because the Wildcats are playing in New Zealand, so that day, so we can do the next live stream will be on Saturday the 1st of May. So yes, I'm a Wildcats member, so so we'll look forward to seeing you back then, and have a great time up until then. Have a great night.
And I'll stop down there at the office before I leave. So
okay, cool. Thanks.
Okay, I'll see you soon.
See ya.
Bye guys.